Hey guys, it's Ms. Marflag here. We're continuing with our next lesson in trigonometry, and that's continuing our work with exact values. The last time we met, we did exact values, and we did them on the interval from 0 to 360 degrees. We did it with both degrees and radians, but we omitted or we did not do any quadrantal angles, any angles that lie on an axis, like pi, or 360 degrees, or 90 degrees, or 3 pi over 2, angles like that. So we're going to spend this video really working with our quadrantal angles in both degrees and radians, and then we're going to just do a few practice problems working with coterminals, angles on different rotations. But the next time we meet in our next video, we're going to spend some more time on coterminals, because after looking at your guys' quizzes and Google Forms and some homework, I saw that this was a little bit of a struggle. So we're going to actually break coterminals up into two videos. So this is the goal today, and then to see a little bit of coterminals. All right, we're going to just do a quick recall of certain things we looked at in our last video. And it's important that we start off the video like this because we're going to be using all of these notes from our recall. One of the past few times we met in a video, we went over our unit circle, and with our unit circle, we saw that our x-coordinate was our cosine and our y-coordinate was our sine. That was because we dropped our triangle in quadrant 1, and the adjacent leg was our x-axis, and the opposite leg was our y-axis. So we're going to quick recall that cosine theta is our x-coordinate on the unit circle, and sine of the angle is our y-coordinate on the unit circle. All right, and then we saw as we built our unit circle that angles that have the same reference angle have the exact same value, except maybe they're just negative or maybe they're positive. But you could see throughout this whole unit circle, we only use a few values like a half, square root of 3, and square root of 2. Square root of 3 over 2 and square root of 2 over 2. So what really matters is where our trig functions are positive and negative. We used a cute acronym to kind of help us remember where our trig functions are positive or negative. And what we did was we plotted our x and y coordinate to see where x's are positive, where y's are positives. And then we used the knowledge that tangent is sine over cosine to see where tangent was positive. When we did all of those things, we saw that in quadrant 1, all of the trig functions were positive. In quadrant 2, we saw that just sine theta was positive. In quadrant 3, we saw that tangent theta is positive. And in quadrant 4, we saw that cosine theta was positive. So if I asked you, okay, an angle is lying in quadrant 2, is the cosine of that angle positive? The answer would be no, just sine is positive. If I said an angle's lying in quadrant 4, is the tangent of that angle is positive? And your answer would be no, tangent is positive only in quadrant 3, and so on. So we use this little all students take calculus to kind of help us remember where the trig functions are positive. And then lastly, the last time we met, we used this laid out formula to help us find the exact value. And the first thing we did together was identify the quadrant that the angle is in. Once we identified which quadrant it was in, we were able to tell whether our final answer was going to be positive or negative using all students take calculus or using your knowledge of x and y coordinates in each quadrant. And then we identified the reference angle. And as we built that unit circle, we saw anything with the same reference angle has the same exact value, except it's either positive or negative. And then once you put together B and C, we had our final answer. And then I asked us on our homework to do this laid out method because I want to really ensure that nobody is using photomath. And more importantly than not using photomath is thinking of these through your head, because in pre-calc, you're going to have to be able to kind of get these answers quickly when we start building on the trigonometry. We're just going to refresh our memory with a few examples of finding the exact value on 0 to 360 degrees before we dive into our quadrantals. Now, when we were finding the exact value, we used this process, and then the only other thing you really needed was your two special right triangles. You needed your 30, 60, 90 triangle, which is 1, square root of 3, and 2, and then you need your 45, 45, 90 triangle. And whenever you're doing trigonometry, you should have these written down. Okay, because you're going to be going back to them over and over and over again. And then we're going to use that unit circle to check our work. We're going to start off with this first one here, and we're going to do sine of 150 degrees. Now, I'm going to use this process, but I'm not going to list out A, B, C, and D. Instead, I'm just kind of save some space and show you how you can do it just a little bit shorthand, but I still want to see all the work that I'm going to show here. All right. 150, well, that's in quadrant 2, where sine is positive, and our reference angle, we're 30 degrees away from the nearest x-axis. So what we do is we do sine of 30 degrees and we keep it positive. So here we are 30 degrees, and that's going to be opposite over hypotenuse, and that's positive 1/2. And there's our answer for the first one. All right, we're going to take a look and find the exact value of number 2, and we're going to do tangent of 3 pi over 4. The radian ones can be a little trickier. All right, 3 pi over 4, that is like saying I'm 3/4 of 1 pi. So here is pi, so 3 pi over 4 would be somewhere right here in the middle of quadrant 2. And then if you're not positive of that, just kind of go back and double check your unit circle. In quadrant 2, tangent would be negative because only sine is positive. And then we're pi over 4 away from the nearest axis, and that's the same as 45 degrees. So what we do is we do tangent of 45 degrees and we make it negative. Okay, that's opposite over adjacent, so my final answer here is -1. All right, and then we're just going to do one more to refresh our memory, and let's see here, we're going to do cosine of 5 pi over 3. All right, 5 pi over 3. Well, that means that we pass 3 pi over 3, and then we're 2/3 of the way to the next pi, and that's going to be here in quadrant 4, where cosine is positive and my reference angle is pi over 3, which is also 60 degrees. So we do cosine of 60 degrees and we make it positive. So here we are adjacent over hypotenuse, and that's going to be positive 1/2. And then let's go through and just double check our answers here. Sine at 150 degrees, well, that's our y coordinate. My y coordinate at 150 should be positive 1/2, and it is. All right, tangent of 3 pi over 4, when I do y over x, I should get -1, and I do. Cosine's my x coordinate, so at 5 pi over 3, my x coordinate better be this answer, 5 pi over 3, and there's my x coordinate, positive 1/2, and all of our answers look good. All right. Now we're going to move on to today's lesson, which is talking about quadrantal angles. So if you need a quick refresher, quadrantal angles are any angle that lies on an x or y axis. I'm just going to put maybe here in parentheses, that's like 0 degrees or pi over 2, or we'll do 270 or pi, and so on, okay? Any angle that lies on a quadrant. All right, so what we saw here with our unit circle is that sine is our y coordinate, cosine is our x coordinate, tangent is y over x, and then it's just the points that are on the unit circle. So that's all we need to know for quadrantals, is that cosine is our x coordinate, sine is our y coordinate on the unit circle, and tangent is our y over x. And the quadrantals are actually a little bit easier, I think, because you really only need to know your 4 coordinate points. So here's your 0 degrees, there's your 90 pi over 2, there's your 180 pi, my 270, which is 3 pi over 2, and my 360, which is 2 pi. And then when you have your unit circle, keep in mind a unit circle has radius 1. So this point here at 0 degrees, 360 degrees, and 2 pi is the coordinate point 1, 0. This coordinate point here is 0, 1. This coordinate point here is -1, 0. And this coordinate point here is 0, -1. All right, and then let's jump into a few practice problems. You can use this little picture here, or you can use the big one, okay? So here we are. My directions are going to be find the exact value. And I'm going to squeeze it down here at the bottom of my page because you actually don't need a lot of work for these. They're pretty short. All right, and then here's the first one. We're going to do sine of 0 degrees. So I'm asking you to find the exact value of sine of 0 degrees. Well, I always like to write down what coordinate I'm looking at here, and sine is my y coordinate. So my y coordinate at 0 degrees is 0. And there's my answer. What? I know, it's so much easier than doing this whole other process that we did at the top of the page because we're just using the points on our unit circle. All right, let's take a look at number 2. Let's say I want to find the exact value of cosine of pi. All right, cosine's my x coordinate, so what's my x coordinate at pi? On the unit circle, my x coordinate is -1. Let's take a look at number 3. We're going to do tangent of 360 degrees. All right, 360 degrees is here. Tangent is y over x because it's sine over cosine, so y over x. My y-coordinate at 360 degrees is 0, and my x-coordinate is 1. 0 divided by 1 is 0. All right, moving on to another sheet, we're continuing with finding the exact value of our quadrantal angles. All right, let's take a look at the next one here, and that's going to be number 4. And we're going to try sine of pi over 2. Okay, well, sine is my y-coordinate. So my y-coordinate on my unit circle at pi over 2 is 1. There's my exact value, 1. Number 5, let's do cosine of 0 degrees. Cosine is my x-coordinate on the unit circle. So at 0 degrees, my x-coordinate is 1. Number 6, we're going to take a look and we'll do tangent of pi over 2. All right, tangent is y over x. Pi over 2 is 90 degrees. My y-coordinate is 1 and my x-coordinate is 0. So we have 1 over 0, and you can't divide by 0. So here at tangent of 90 degrees or pi over 2, that answer is undefined. That answer is undefined. The function does not exist at that point, degrees, 90 and pi over 2. All right, number 7, we're going to do cosine of 90 degrees. All right, well, cosine's my x-coordinate, and my x-coordinate at 90 degrees is 0. A few more here. Number 8, we're going to do sine of 3 pi over 2. Sine of 3 pi over 2, well, that's my y-coordinate, and my y-coordinate at 3 pi over 2, or 270 degrees, is -1. And there's my answer for sine of 3 pi over 2. Number 9, we're going to have tangent of 180 degrees. Tangent is y over x, so we're going to take a look at our coordinate points on our unit circle. My y is 0, my x is -1, so I have 0 over -1, which is 0. I can have 0 in the numerator. Number 10, we're going to do cosine of 270 degrees. All right, cosine's my x-coordinate, so my x-coordinate at 270 degrees is 0. Number 11, we're going to do sine of 180 degrees. Sine is my y-coordinate, and my y-coordinate at 180 degrees is 0. Number 12, we'll do tangent of 3 pi over 2. All right, tangent is y over x, and at 3 pi over 2, my y-coordinate is -1, and my x-coordinate is 0. So we do -1 over 0, and there's that division by 0 again, and that's another undefined. So tangent's undefined at 90, which is pi over 2, and 270 degrees, which is 3 pi over 2. We're going to do sine of 2 pi. That's going to be our y-coordinate. We're going to find 2 pi on our unit circle, and here it is. My y-coordinate is 0. And then 2 more to go here. We're going to take a look at 14. We're going to do cosine of 360 degrees. And 360 degrees is the same as 2 pi. And I'm looking at my x-coordinate now, and my x-coordinate is 1. And then here's the last one, just so that we have plenty of examples. And we're going to have tangent of 0 degrees, and that's still going to be y over x. And at 0 degrees here, we're going to have y over x, and that's 0 over 1, and that's going to be 0 again. All right, so every time you're doing these practice problems, you don't maybe have to have this big unit circle. Instead, you could just draw this tiny little one that doesn't show all of the angles like this one does, but just shows the quadrantal angles and the coordinate points of the quadrantal angles. Once you get really good at this, even my kids at my pre-calc level, they could do most of this in their head. So once you know your coordinate, just those 4 coordinate points, you get comfortable with the fact that sine's y, cosine is x, and tangent is y over x, then actually the quadrantal angles are probably easier than finding the exact value of any other angle on the unit circle. All right, we're going to move on from quadrantal angles like I said we would, and we're just going to do a little introduction to coterminal angles. This is where I think things get a little tricky, but we're going to take our time and we're going to split it up over the course of 2 videos. So in our next video, we're going to have coterminals and negative angles, and then that's going to be the last video for exact values. So you can expect one more video, a review day, and then a very big test. All right, so if you're having some trouble, please reach out to me. All right, here we are. We're going to list out here that we're going to be now finding the exact value 2, I'm changing colors because we're switching topics, and we're going to be doing coterminals. And then if you need a little refresher on what a coterminal angle is, it's an angle that shares, it's two angles that share the same initial and terminal side. It could be 3 angles, 4, but these angles are really in the exact same place on the unit circle. They're just on different revolutions. And then if you're remembering maybe that algebraic way to model it, we could add or subtract 360 degrees. And then if we're working in radians, we added or subtracted 2 pi. And then this would be just one full revolution. And that's how we found a coterminal. All right, now our directions here are going to be find the exact value. And we're going to evaluate the first one, and number 1 is sine of 405 degrees. Some people like to draw the angle in standard form. If you're more of a visual person, go for it. Take the time, draw it out. That might help. But what I personally like to do is right off to the side here is solve right off the bat for a coterminal. So I know that this is past 360 degrees. So I want a coterminal. So I'm going to take 405 and I'm going to be subtracting my 360 degrees. I have 5 minus 0, which is 5. I borrow from the 4, and then I have 45 degrees. So sine of 405 degrees is the same as sine of 45 degrees. That's because 45 degrees and 405 degrees are coterminal. And then now we can use the process that we used earlier, and that's finding out what quadrant it's in, whether or not it's positive and negative, what's the reference angle, and then using our beautiful triangles to tell us our final answer. And our answer here is going to be square root of 2 over 2. Now, while we're doing these problems, you're going to see that I'm going to be pulling out this green sheet. I attached it in our last classwork. It kind of has all of our beautiful notes here, especially right triangles, our ratios, degree and radian conversion, the 3 reference angles that you need to know by heart, your quadrants and your axes you need to know by heart. You're also need to take calculus, steps for finding the exact value, and then I added in now today our quadrantals and our little unit circle that'll help us with our quadrantals. So once again, sine of 45 degrees would be opposite over hypotenuse, and then we rationalize and we get square root of 2 over 2. And then when I go to check here, my y coordinate at 45 degrees should be square root of 2 over 2, and it is. All right, good. Now we can move on. Number 2, we'll do another degree one, and then we'll go to a radian. Here we are, we're going to take a look at cosine of 480 degrees. All right, so I see 480 degrees is past 360, so I'm going to take that 480, and I'm going to subtract a revolution to solve for a coterminal angle. And then I see here that cosine of 480 degrees is the same answer as cosine of 120. These are coterminal. And then we know already from previous videos how to solve cosine of 120, and we identify that that's in quadrant 2, where cosine is negative, sine is positive, and we're 60 degrees away from that nearest x-axis. So then I do cosine of 60 degrees, which is adjacent over hypotenuse, and I make it negative, and I get negative 1/2 here. And then that's my answer for cosine of 480 degrees. The answer is negative 1/2. All right, moving on to number 3 here. We don't have many examples, and we're going to do sine of 8 pi over 3. All right, so now we're working with radians, but the process is still the same. I see 8 pi over 3 is past 2 pi on my unit circle. So I'm going to start off with 8 pi over 3, and I'm going to be subtracting 2 pi, just like I would subtract 360 degrees. But I need a common denominator, so 2 pi is the same as 6 pi over 3. And then when I go ahead and subtract, I get my coterminal angle is 2 pi over 3. It's a real common mistake for people to subtract 3 pi over 3. Remember, pi is not a full revolution, so you're either adding and subtracting 360 degrees or adding and subtracting 2 pi. All right, and then now we see that 8 pi over 3 and 2 pi over 3 are coterminal, so they have the same exact value. Now we can use our knowledge and solve for sine of 2 pi over 3. Well, that's going to be in quadrant. If I'm 2/3 of the way to pi, that means I'm in quadrant 2, where sine is positive, and my reference angle is pi over 3, which is 60 degrees. See how I'm using my little chart I made for you guys? And then now we do sine of 60 degrees and we leave it positive. So sine of 60 degrees is opposite over hypotenuse, and we get square root of 3 over 2. And once again, this is the answer to both of these. All right, we got 2 more for you. I hope I can squeeze them in on this page. We'll put number 4 up here in my effort. to not have to use another sheet of paper. All right, let's do this. Let's do cosine of 900 degrees. All right, I see 900 degrees is past 360, so let's go ahead and do some subtraction. And I'm going to subtract a revolution. I have 0. I regroup the 9 and regroup the 0 to a 10, and I have 540 degrees. And then I look at 540 degrees, and that's still past 360. So I'm going to go ahead and I'm going to subtract another revolution here. Once again, borrowing from the 5, regrouping the 4, and we're going to get 8, and we have 180 degrees. So cosine of 900 degrees is the exact same value of cosine of 180 degrees. 180 is also pi, and some bells should be going off in your head that this is a quadrantal angle, which means I just need my coordinate point, which is my x-coordinate. I'm going to take a look at my x-coordinate at 180 degrees, and that is -1. And then there's my final answer boxed in. And then, yay, I did it. We're just going to fit this last one in here, and that's number 5. Did I do a tangent one? No, I did not. So we'll make up a tangent one. Here we are, tangent. And we'll do 29 pi over 6. Okay. Once again, 29 pi over 6 is in radians, and it is way past 2 pi. So let's do some of that subtraction. We're going to do, maybe I'll do it here, 29 pi over 6. Let's subtract a revolution. So I need to subtract 2 pi, which is 12 pi over 6. Then when I do the subtraction here, I'm going to get 17 pi over 6. And then that's still past 2 pi. So let's do another rotation. And I see here that I'm really evaluating tangent of 5 pi over 6. So tangent of 29 pi over 6 is the same as tangent of 5 pi over 6. And then we use the same process we used before. We ask ourselves what quadrant this is in. Well, if I'm 5/6 of the way to pi, I'm in quadrant 2, where tangent is negative and my reference is pi over 6, which is 30 degrees. So I do tangent of 30 degrees and make it negative. Tangent of 30 degrees would be opposite over adjacent, which is 1 over square root of 3, and I rationalize and I get negative square root of 3 over 3. Sorry that I squished that last one in there, but I don't want to waste paper. Okay. That's it for today. I love how I say that's it, like we didn't do much, but we did a lot, took a lot of notes. And once again, we did exact values with quadrantals, and we'll see definitely coterminals again. All right, make sure you start reaching out to me if you're feeling overwhelmed, or if this is, confusing. I can send you some Khan Academy links, because like I keep saying, we are going to be having an assessment coming up soon, and we've taken a few quizzes already, and you'll see your first test here when it comes with trigonometry. All right, so email me if you have any questions. Bye, guys.